In the last video, we have discussed about the integration steps for the active and passive devices in the IC, like transistors, resistor, capacitors, that and all, how these active and passive elements integrated in IC, we have discussed about that. Now in this video, we will see about operational amplifier. Operational amplifier, we can call it as op-amp. This op-amp can perform various operations like addition, subtraction, integration, differentiation, and so on. This op-amp is specifically used in analog computer. So in analog computer, we can see this op-amp. Next, an operational amplifier is an integrated circuit that can amplify weak electric signals. An operational amplifier has two input pins and one output pin. Its basic role is to amplify and output the voltage difference between two input pins. It's a low-cost integrating circuit consisting of transistors, resistors, and capacitors. The operational amplifier is a versatile device that can be used to amplify AC as well as DC input signals and designed for computing mathematical functions such as addition, subtraction, multiplication, integration, and differentiation. The operational amplifier, most commonly referred as op-amp, was introduced in 1940s. The first operational amplifier was designed in 1948 using vacuum tubes like this. In those days, it was used in the analog computers to perform a variety of mathematical operations such as addition, subtraction, multiplication, etc. Due to its use in performing mathematical operations, it has been given a name operational amplifier. Due to the use of vacuum tubes, the early op-amps were bulky, power-consuming, and expensive. Robert J. Wilder at Fairchild brought out the popular 741 integrated circuit op-amp between 1964 to 1968. The IC version of op-amp uses BGTs and FETs, which are fabricated along with the other supporting components on a single semiconductor chip or wafer, which is of a pinhead size. With the help of IC op-amp, the circuit design becomes very simple. The variety of useful circuits can be built without the necessity of knowing about the complex internal circuitry. Moreover, IC op-amps are inexpensive, take up less space, and consume less power. The IC op-amp has become an integral part of almost every electronic circuit, which uses linear integrated circuit. The modern linear IC op-amp works at lower voltages. It is so low in cost that millions are now in use annually. Next, we will see about the use of op-amps. Op-amps are commonly used for both linear and non-linear application. For linear applications, it can perform amplification. It can be used as a summers, integrators, differentiator, and filter. As a non-linear application, it can be used as a comparators, analog to digital converters, and Smith trigger. This is the symbol of an op-amp along with its various terminals. is shown in this slide. The up is indicated basically by a triangle which points in the direction of the signal flow. The op-amp consists of 5 terminals. The positive supply terminal VCC or plus volt, the negative voltage supply terminal minus VE or minus volt, the output terminal, the inverting input terminal marked as negative, and the non-inverting input terminal marked as positive. The 741 op-amp is a monolithic integrated circuit comprising of a general purpose operational amplifier. The number 741 indicates that this operational amplifier IC has 7 functional pins, 4 pins capable of taking input and one output pin. Okay, so here we are having 7 functional pins. This pin number 8 will not in use. So 7 functional pins totally and 4 input pins. Inverting input, non-inverting input, power supply, a dual voltage supply we have to give. So totally we are having 4 input pins and 1 output pin. So that is called 741, IC 741. Here, this is the pin configuration of IC 741. Here, pin 4 and pin 7. Pin 7 is the positive voltage supply terminal. Pin 4 is the negative voltage supply terminal. The 741 IC draws in power for its operation from these pins. Similarly, pin 6 is the output pin of IC 741. Like that, pin 2 and pin 3 are input pins. These are the input pins for the IC. Pin 2 is the inverting input and pin 3 is the non-inverting input. If the voltage at pin 2 is greater than the voltage at pin 3, that is the voltage at inverting input is higher. The output signal stays slow. Similarly, if the voltage at pin 3 is greater than the voltage at pin 2, that is the voltage at non-inverting input is high. Hence the output goes high. Like this pin 1 and pin number 5 denotes offset null because of high gain provided by 741 op-amp. Even slight differences in voltages at the inverting and non-inverting inputs caused due to irregularities in manufacturing process or external disturbances can influence the output. To nullify this effect, an offset voltage can be applied at pin 1 and pin 5 and is usually done using a potentiometer. Pin number 8 is officially noted as not connected ENC. This pin is not connected to any circuit inside 741 IC. It's just a dummy lead used to fill the white space in standard 8-pin packages. So that's all about IC 741 operational amplifier. And in the upcoming video, we will see about ideal, what is meant by ideal op-amp and their characteristics. Thank you.